Hi everyone, and today we're going to look at inverse functions. An inverse function, written as f with a little power of -1, exists when the original function has a one-to-one correspondence. This means that each element in set A corresponds to one element in set B. For every x value, there is one and only one y value, and vice versa. So here we have elements in set A 1, 2, 3 and 4 and elements in set B 3, 6, 9 and 12. So from set A to set B, f of x is going to be what happens from set A to set B. Okay, so we can see that the 1 goes to the 3, the 2 goes to the 6, 3 goes to the 9, the 4 goes to the 12. That's quite a simple one, and that is a multiply by 3. So every element in set A goes to one and only one element in set B, and vice versa. So you could say that f of x is 3x. And to go backwards from set B to set A, we'll call it a different function this time, we'll call it g of x. We would divide by 3, and you can see the arrows are going backwards there, so we're going backwards there, okay? And we would be dividing by 3. So the function g of x would be x divided by 3, okay? So as there is a one-to-one correspondence, f of x and g of x are inverses of each other. Okay, if f of x is equal to 2x plus 6, find the inverse function of x. So we start off by writing f of x equal to y. We know that from that 5, that f of x is equal to y. Okay, so we rewrite it as y equals 2x plus 6. And we want to rearrange for x being the subject of the formula this time. Okay, because if we have originally y equals 2x plus 6, we want to rearrange it so we know then, well, what would be the x value if y was the input? So we're doing everything in reverse. So we start to rearrange it, just switch sides. Let's take the 6 over, make it a takeaway 6, and take the 2 over, make it a divide. So I've divided each of them by the 2 individually, or I could have just written a whole line over 2 there, y minus 6 all over 2, or the y over 2 minus the 6 over 2, which is y over 2 minus 3. And then what you want to do next is change the x here back to your inverse function of x, which is what you're asked to change it to, and then you're going to change that y back to the x that you have originally. Okay, so you just rewrite that there as inverse function of x, you rewrite that little y, change it back to the x, and everything else is the same function. So it's the input divided by 2, take away 3, but you're making the input the x again, because it's the original x value with the inverse function. Okay, so here's another one. If we have f of x equals x cubed take away 4, find the inverse function of x. So we'll do the same thing. We'll rewrite it, but instead of f of x, we'll rewrite it as y equals x cubed minus 4. So it's the same function, but we're replacing f of x with y. Now we want to rearrange it and change the subject to the formula to x equals. Okay, so switch sides, take the negative 4 over, make it a plus 4, and take the cube over and make it a cubed root. Now we want to then replace that back with the inverse function of x and that little y there with the x. And that's how you do inverse functions. Now, something that's important from the composition of functions that we had done previously. When we were doing the composition of functions, I did say at the time that generally f of g of x and g of f of x are generally not the same answer, okay? But if you find the composition of functions f of g of x and your final answer is x, then the functions are inverses of each other, so long as there is one-to-one correspondence. What this means is, if you start off with one function, and if you go through f of x to get to your answer, start off with a set of numbers, and you go through f of x to get to your set of answers, and then you go back through g of x, And if that takes you back to x again, it means it takes you back to your original set. And that's why f of g of x, if it's equal to x, it means that they are inverses of each other. Whatever you do from one set of numbers to get to the answer, g of x will completely take you back to your original set, which is your original x's. And that's the only occasion when you find f of x and g of x is equal to g of x and f of x. And there we have it there. So the inverse function of f of x is equal to the function of the inverse function of x, which is equal to x. So you might get asked a question like this. Show that g is the inverse of f. If f of x is equal to 3x minus 9 and g of x is equal to 1/3 x plus 3. So if you're asked to show that they are inverses of each other, then a function of a function should lead to x. So let's start with f of g of x and see what happens. So remember how we do the composition of functions. We start with the inside and we're going to put the g function into that bracket and replace it with that. So the g function is 1/3 x plus 3. So we'll write 1/3 x plus 3 and we still get f out there. Now we go back to the f function. We reread the f function as f of the bracket equals 3 times the bracket take away 9. This is now your bracket. So where they have the bracket here has to match the bracket there. F of the bracket equals 3 times the bracket take away 9. So if it's 3 times the bracket take away 9, this is your bracket. It'll be 3 times that bracket there, take away 9. Now we'll multiply out that bracket. 3 times 1/3 x is x. 3 times 3 is 9, take away 9. X plus 9 take away 9 is x. So we have x as we would expect to have. You've got to remember though that if it's an inverse function of each other, the answer is x. Okay, that's how you show that and demonstrate that. So g is the inverse of f, as f of g of x is equal to x. Equally, if you had done g of f of x, you would have also got x as your answer because they are the inverses of each other. Okay, now what about functions that we're familiar with as being inverses? If we think of them in the calculator, that an x squared and a root x square root x, they are the inverses of each other. Well, what about this if we look at it? F of x equals x squared and g of x equals the square root of x. Is g of x an inverse function of f of x? Let's look at some sets of numbers. So we have in set A, -2, -1, 0, 1 and 2. And in set B, we have some answers that we'll get when we go from f of x to g of x. Okay, so let's square all of our numbers. -2 squared leads to 4. So we're doing the f of x function to go from left to right. -1 squared leads to 1. 0 squared leads to 0. But here's the problem. 1 squared also leads to 1. And 2 squared also leads to 2. And every element in set A should go to 1 and only one element in set B. And every element in set B should go to 1 and only one element in set A. So we do have a problem. So technically f of x being equal to x squared and g of x being equal to root x are not actually inverses of each other unless we do something which is called restricting the domain. The domain are your input numbers. So if we restrict the input numbers, then we do have an official inverse function. There is not one-to-one correspondence here, as we can see. So they're not technically inverses of each other unless we restrict the domain. And for example, make x's all of the whole numbers. So if x's were all of the whole numbers here, then yes, they would have a one-to-one correspondence. And if we didn't have the negatives involved in that input set of numbers there, then that can be the thing that you have to watch out for. That can also be the case with some trig functions as well. If you're to look at the sine graph and then draw the inverse sine graph, then you'll realise that you have to restrict the domain to have it to be a proper inverse function as well. Okay, so we're now going to look at exercise 2D and we'll do questions 1 to 5. And as always, let your teacher know if you have any problems, and good luck and take care.